Good day, folks. Welcome to my YouTube channel. If you're new here, please subscribe. Watch my video while you subscribe. About 66% of you guys watching my video without subscribing. Subscribing, guys, it doesn't cost anything. You don't have any, there's no obligation of anything, financial obligation. It's just you just supporting me when you subscribing. So guys, watch my video while you subscribe and like all my videos. Watch my videos till the end, comment there. You can react on my video. I'm on my road to 2k, which is 2,000 subscribers. It's all you guys who have done that. Thank you for the support. Continue watching my video, supporting me, and I'll continue making nice videos. Now we're going to look at the graph interpretation we're going to look at the graph of concentration versus time and reaction rate versus time graph. When all factors are changed, we're going to see how the temperature is changed, concentration, pressure is changed in both graph. These two graph, guys, they mean the same thing, but this one is a concentration, this one is a rate of reaction, but we're going to see in different factors how the factors are changed. Let's cut the chase, guys. Having this reaction here, this reaction is reversible. It's supposed to have double arrows there. Okay, fine. Now since this is exo, that means our forward is what is exo, and then our reverse is what is endothermic reaction. If you're looking here as well, we have three number of moles, which is 1 plus 2, it's what, it's 3 number of moles in the reactants, and then in the product we have what, 2 mole of gases there. Right, let's start from the beginning in the concentration versus time graph. This one is the nitrogen oxide, and this is the oxygen, and then the product will be nitrogen dioxide. Right, now from the beginning, if you see, we have a high concentration of the reactants, which is the nitrogen oxide and the oxygen. As the reaction progresses, okay, before the reaction started, the concentration of the product, which is the nitrogen dioxide, is 0. As the reaction starts, their concentration decreases, and what's happening in the product is formed, and the concentration of product is gradually increasing there up until both reactants and products are at equilibrium. So at this point here, they're at equilibrium, they're starting the equilibrium there, right? If you see there, the concentration of the reactants are constant, and the concentration of product is what, constant there as well, up until at this point. So we'll say this is point 1. So we'll look at the beginning of this point 1. I hope you can see the gray shaded part here. So here there is a disturbance here. What happened here? We're going to look at the concentration of reactants and product. If you're looking here, the reactant increases, which is the nitrogen oxide, and the oxygen increases, and the product after equilibrium, right? The product increases there. So when both reactant concentration of reactants and product increases, so that means there's an increase in pressure. So I'll write 1. So 1, what happened there, the disturbance, it was an increase in what? In pressure, right? That was an increase in pressure. Now, we know theoretically, increase in pressure favors the side with the less number of moles. So the side with the less number of moles is the product. Sorry. The side with the less number of moles, which is the product, which is the forward. So the forward reaction is what? Is favored. So here, forward is favored, right? Forward reaction is favored there. It favors the side with the less number of moles, right? Now let's see another thing. So all of them are increase. Let's see the response of the system. The reactant, what does it do in the reactant? After it has increases, the system decrease it, and even there, the oxygen, after it has increased, the system what? decreases. And then what's happening to the product? Do you see the product, which is this one? What's happening to the product? The system, what does it do? It increases. So which means the concentration of this, it has increased because a forward is what is favored. So the concentration of the nitrogen oxide increases. I hope that makes sense, guys. So that was the pressure. The main thing there, what was the disturbance there? It's a pressure increase. Now let's look at the pressure increase in terms of this graph, guys. These are the same graph, but this one is a rate. It shows the rate. This one, it shows the concentration. Let's look at T1 there. Let's look at 1 there. This is also 1. Do you see? This is also 1. This part is the same thing. Now let's see if I was correct when I say forward is favored. Do you see the forward reaction what increases more? Right? They both increase. That's a very important part, guys. After equilibrium, they both increases. But if there's a one that increases more, if there's a one that increases more, and that one it's a spike, we call it a spike, or it's a deep. There's a spike there. That spike means that forward is what? Favored. This one means forward favored. Forward is favored. The forward is favored, guys. Let's say you did not have this graph, you only have this one. So you see here, okay, forward is favored. Okay, when forward is favored, okay, this one, it can only be the temperature or the pressure only. It cannot be the concentration, because the concentration, it curves here immediately. This one, the reverse, was going to curve here immediately. Right, so this one is a pressure or the temperature. Now that let's see, because they increases both from the beginning after the disturbance. As soon as it was disturbed, they increase both for some time, so it can only be the pressure. So the one that increases more is the one that is favored, which is the forward there. Now let's look at number 2. Let's look at number 2. Number 2, what happened in number 2? In number 2 here, let's look at it has it reinstated another equilibrium after the disturbance. It reinstated the new equilibrium. They are now at equilibrium, and now there's another disturbance at 2, right? At 2. So what happened at 2? At 2, let's look. The concentration of NO decreases sharply, and then the concentration of the oxygen, do you see, it has decreased. And look at the concentration of the product, it has decreased both. So when all concentration of the reaction decreases, when all concentration of the reaction decreases, that's a decrease in pressure. It's very important. Decrease in pressure, guys. That happens in the concentration versus time graph. So this is a what? Pressure, right? Now what is important now? Which one is favored? Let's look at after the O decrease, what happened? Look at the NO2, which is the reactant. The system has what? Increased it after. And then let's look at the oxygen, which is the reactant. After the decrease, the system has what? Increased it. But look at the product, which is the nitrogen dioxide. After the decreased, the system has what? Decreased it further. All right, that simply means that the reverse is favored because the reactance has been increased by the system. Look at the reactance. This reactant and this reactant has been increased by the system. So that means the reverse is what? Reverse is favored. Reverse is favored. And then another thing, if the reverse is favored, what happened? What increases? The concentration of nitrogen oxide and the concentration of oxygen increases. Right? If they increases, that means that's the reverse that is favored. So let's look at the rate at 2, the rate versus time graph. Guys, in the pressure, they they will decrease the rate of reverse and forward. They decrease both, but the one that decreases less, do you see the forward decreases more? That means it's not favored. The one that decreases less, look at the reverse decreases less, right, up until they reach equilibrium. That means it's the what is the reverse that is what favored, because it decreases less. Remember guys, in the pressure they decrease both for some time, and there's a one that decreases more and there's a one that decreases less. The one that decreases less, that means is the what is the one that is favored. So the reverse is what is favored, right? You can even tell it's the pressure because they both decreases for some time um, together, right? Now let's go to a third disturbance and see what's happening after equilibrium. There, if you see there's a new equilibrium reinstated there, but now there's a change in the reactants and products, right? The change in reactants and products, like look here, if you see the oxygen, the nitrogen oxide, this the nitrogen oxide, do you see there's a gentle decrease in it? And the oxygen, look at the oxygen, there's a spike there. Once there's a spike there guys, there's the others are gentle and there's only one spike. Do you see the spike there? There's a sudden spike there, or the sharp spike there. That means this is the concentration guys. Do you see this one is gentle and this one is gentle, and this one is a what? There's a spike. So here simply means that this is oxygen guys, this is oxygen. If you follow the curve correctly, the spike is an oxygen. So 3, that means here concentration of oxygen has been what? Increased. There's an increase in the concentration of what? Of oxygen. Now let's look. So once there's an increase in the concentration of oxygen, the system, what is going to respond to do is going to decrease that concentration, right? The system decreases the concentration of oxygen and also decreases the concentration of nitrogen oxide, which is what has been happening there. The disturbance was the increase in concentration of oxygen. The system responded by decreasing it, and it decreases the nitrogen oxide and increases the nitrogen dioxide. This is what happened. Look at the nitrogen dioxide, it has increased, but the reactants, the system responded by decreasing them after there was an increase, which is the disturbance there. So which one is going to be favored there? The favor, it's going to be the one that has been increased by the system. The system increases the what? The forward, increases the product. Do you see the product has been increased there? So if the product has been increased there, that means forward is favored. The forward is favored, and then the concentration of nitrogen dioxide what? Increases. That was increased by the system, right? I hope this is making sense guys thus far. That was 3. Let's look at the rate at 3 when the concentration. How do you see that is the concentration of oxygen now? The concentration of oxygen that has been increased. Now if you look there, it's equilibrium, then at 3 there's a disturbance. Now in this disturbance we see that the forward is what? Is favored, right? The forward is favored. How do you see the forward is favored? Guys, another thing, before how do you know this is a concentration? The other will gradually increase there, and the other will gently increase. Do you see the difference between these two? These two, they decrease both, they increase both, but these ones, even though they increase both, but this one, it curves from the beginning, and this one just gradually increase. So here we can see this is what? This is concentration, right? Okay, let me write them here. This one was what? This one was increase in what? In pressure. And this one was decrease in pressure. Now this one is a increase in concentration. Increase in concentration. Concentration of what? Of oxygen. Right? So this increase in concentration of oxygen, I can see this is concentration, but in this concentration that there has been in this concentration here that has been increased, right? It should be in the reactants. It should be here because I can see there's an increase, right? There's an increase in both rate, but this one gradually increase and this one gently increase. So this is a concentration. But now how do I know it's oxygen? Because it can be, it will be here in the reactants because forward is favored. So the increase is in this side, in the reactants. So if we say the concentration of oxygen has been increased, the system is going to respond by decrease it, and it decreases that, and then this one will be favored. So that's why I say it's here, it's between the two. It's between the two. But even this one, if you increase the concentration of this one, the system will respond by decreasing it and decreasing it and increase that side. So here in this case we'll say it's a concentration of oxygen. It can be the concentration of that, right? Both, any of those, because this one has been what? Increased by the response of the system because forward is favored, right? Okay, now let's go to 3. Let's go to 3 now. 3, let's go to 4, not 3, let's go to 4. In 4, the system reinstated the equilibrium there, if you see. Now here, there's a disturbance at 4. But at this 4, there's a gentle and the spike. Once there are gentle and the spike, you look at the one spike. If there's one spike there, that's the concentration that has been changed. But at this spike, it's a spike that decreases. So that's a decrease in concentration, right? So I know for sure. So here, let me write it again. Here it's a pressure increase. It's a pressure increase and a pressure decrease and the concentration increase. Here, since there's a spike that goes down, or there's a deep, let's say there's a deep there, there's a sharp deep, it's a concentration. It's a decrease in what? In concentration. But now in this case, it's oxygen. It's an oxygen. Let's see, how is it oxygen? So, okay, this is not oxygen here. Let me not say it's oxygen here. Let's see, what is it? What is it, in fact? If you're looking here, there's a decrease in what? In nitrogen oxide. The nitrogen oxide, there's a decrease in concentration. The system responded by increasing it. So there's a decrease, there was a decrease there, and the system responded by increasing it. If it increased that, it needs to increase the other reactant and decrease the product. So there, it's a nitrogen what? Oxide. It's a nitrogen oxide there. It's a concentration of what? Of nitrogen oxide that has been decreased. Look at that. The decrease in concentration of nitrogen oxide, the system respond by increasing it, and the other reactant, it increases as well, which is the oxygen. And then the product, it what? It decreased. Do you see the product? It is what? Decreased, right? So which one is favored here? Which one is favored here? The one that is favored here is the reverse. Because the concentration of nitrogen oxide is increased and the oxygen is what? Increased. So reverse is favored. So what are we going to say? We say the concentration of nitrogen oxide has been what? Increased. Right? And which one is favored? Is the reverse reaction is favored. Reverse is favored there. And then what's happening? The concentration. No, it's not increased here, it's decreased. The concentration of nitrogen dioxide is what? Decreased. That's the disturbance. And then the system responding by increasing. So the nitrogen oxide and oxygen concentration is what? Increased by the system, right? Has been increased by the system. Let's look at this curve in the rate of reaction curve. You see there's a spike there and there's a gentle. So that simply means this is a what? This is a concentration. It should be a concentration that has been what? Decreased. Why do you conclude that concentration decrease? Immediately after equilibrium there's a gentle decrease, and there's a spike, or there's a deep that decreases sharply there. So the one that decreases more is not favored. The one that decreases less is the one that is favored. So the one that is favored is what? It's reverse. So reverse is favored. Do you see? When reverse is favored, it simply means that the concentration of nitrogen oxide was decreased and the system responded by increasing both reactants. That means the reverse is what? Is favored, right? So here it simply tells us the reverse is what? Is favored because it decreases less, right? Okay, let's move to 5 now. Let's move to 5. I'm looking at 5. Looking at 5 here. At 5, after equilibrium, there are gentle curves. There are gentle curves. Do you see? After equilibrium, there are gentle curve. There's a gentle increase, and a decrease. Okay, right? Once there's a gentle increase and decrease, whatever, as long as it's gentle, there's no spike. They're all gentle. That means it's a what? It's a temperature. This is a what? This is a temperature. But how do we know it's a temperature increase or a temperature decrease? Okay, let's look at which one has been increased. The oxygen concentration increases and the nitrogen oxide increases. That means the reverse is favored, right? So when the reverse is favored, what is our reverse in this case? Is what? Is endo. So that means reverse is favored and the reverse is what? Is endo. Reverse is endo. That means that this is a temperature increase. There was a temperature increase here. So let's look at okay, let's write 4 here. 4, there's a temperature what? Increase, right? There's a temperature increase there. Let's prove it by the rate of reaction graph. The rate of reaction graph here, guys, very important here. In the temperature, guys, if there's an increase in temperature, both reverse and forward reaction will increase for a short while. It's not the same as the pressure. Do you see? The pressure increases for a while. Do you see? But in this one, they both increase for a they increase for a short while. Here the pressure, they increase for a little bit longer. This one increases for a short while. Now here forward is favored. Okay, no, that's not forward, that's reverse. Reverse is favored. Okay, so if reverse is favored here, that means that there was a increase in temperature, because increase in temperature favors what? Endo. So reverse is favored. So here I can even confirm that the temperature has been what? Increased, because the reverse has been favored. So reverse that is favored, that means it's endo. So if endo, we know theoretically endo is the reverse. Endo is an increase in temperature. So this one increases more and this one increases less up until they reach equilibrium there. So the reverse is favored, which is, so what we can say here in terms of writing, we can say reverse is favored. right? The reverse is favored, and endothermic reaction, reaction, endothermic reaction is favored, right? That's very important, guys. I hope it's really making sense now. Okay, let's look at the last one, which is 6. It's 6. I hope you can see. Do you see there? That gentle increase, decrease there. So once there's a gentle, there's no sharp in the concentration versus type graph. It means that it's the temperature. You can all see there in that disturbance, they're all gentle. That means it's a temperature. But let's see if it's a temperature increase or a temperature decrease. Now, let's look what's happening there. Let's look at the reactant, which is the oxygen. The oxygen decreases. Let's look at the nitrogen oxide, which is the reactant. It decreases as well, right? When they both decreases, look at the product. The product, it increases. Oh, that means forward is favored because the concentration of nitrogen oxide increases. The concentration of nitrogen oxide increases. That means the forward is favored. So if the forward is favored, that means exo is what? Is favored. So when exo is favored, we know theoretically exo is a decrease in temperature. So there's a decrease in temperature. Looking at it at the graph of what? A graph of rate. Okay, they both decreases for a short while, right? When they decrease for a short while, that means it's a what? It's a temperature. It can only be a pressure or a temperature, but they decrease for a short while, so that means it's a temperature. But now in this, let's say we did not know which one between the two. Is it the is it the pressure or the concentration? Okay, so they decrease for a short while. There's one that decreases more. The one that decreases more, it's what? It's reverse. Okay, and then there's a one that decreases less, which is forward. So the one that decreases less is the one that is favored, which is it's forward. Forward is favored. Remember, forward is favored. This is number 5, guys. This is not 4. This is number 5. So number 6. So it's a decrease in temperature. So forward is favored. It's a decrease in temperature, which is exo. So here the temperature has been what? Decreased. So the decrease in temperature, that means the forward reaction is what? Is favored, right? And lastly, which means that if it's forward, the exothermic reaction is favored, right? The exothermic reaction is favored. I hope, guys, that makes sense. Now in the next video, I'm going to do questions now where we answer the graph questions. I hope that makes sense, guys. Cheers. Bye.